Hi everyone, so in this video I want to show you how to solve quadratic equation by completing the square. Okay, so this is an example. So this is a quadratic equation made of three terms. Okay, quadratic trinomial. So to complete the square, step one, I'm going to collect the variable terms on the left. So I have to move the constant on the right side of the equal sign. So I have to minus 25 on both sides. So the new equation is going to be 4x squared minus 20x equal to negative 25. So now to complete the square, the x squared needs to be by itself. What I'm trying to say here is the number in front of x squared needs to be 1. Okay, so that's for x squared. You just want to see x squared. Right now I see there is a 4 in front of x squared. 4 is being multiplied to x squared. So to make a to be 1, so what I have to do here, I have to divide both sides by 4. Why? Because I need the coefficient of x squared to be 1, so I can complete the square. Otherwise, you cannot do that. Okay, so you end up with x squared minus 5x equal to negative 25 over 4. So now the next step is, uh, so again, you want to have the variable on the left and the constant on the right. That's why minus 25. Then x squared needs to be a coefficient, as a coefficient of 1. So earlier I divide by 4 on both sides. Okay. Then right now we need to find a number. What number would you add to this quadratic on the left side to have a perfect square? So how do we get that number? So it's pretty simple. Okay, so no, the number to add here, you're going to take half of b, which is negative 5 over 2, and you're going to square it. Okay, so you take half of b, which is negative 5 over 2, and you square it. So I end up with negative 5 over 2 times negative 5 over 2 by simplifying to 25 over 4. So what number am I going to add here? It's going to be 25 over 4. And remember, whatever I do on one side, I have to do it on the other side to balance the equation. Okay, so I'm going to add 25 over 4. So now I'm going to factor the left side. Okay, so I end up with x. Again, the number to write as a square, to write this trinomial as a squared. Okay, so I'm going to start with the x, the x squared is x squared. And then I'm going to use half of b. b here is negative 5 divided by 2 is going to be negative 5 over 2. So that's why I have to write minus 5 over 2, everything squared, equal to, those two are opposite of each other, that's equal to 0. Okay? So now I want to get to x. Right now I cannot because of the square. So what operation do you use to undo the square? Okay, you're right. So you're going to take the square root on both sides. So now when you take the square root on both sides, always include the plus or the minus, okay, sign. So you end up, so now the square root is going to undo the square, so you're left with x minus 5 over 2 equal to, because it's plus and minus 0, and 0 is neutral, it just can be just 0, okay? It's only work, you don't need the plus and minus for 0, okay? But still, it's two numbers, plus 0 and minus 0 is 0, okay? So now, what do I do next? Okay, so to solve for x here, I need to add 5 over 2 on both sides. So the new equation is going to be x equal to 5 over 2. Okay, so now how would you solve? So the solutions, so you have one solution, which is 5 over 2. Okay, and even though it's one solution, you only see one number, but it's actually two numbers that have the same sign. I mean the same value, okay? Again, why do I have two numbers? Because one is a positive and negative 0, but positive and negative 0 add up to just 0, okay? So we still have two, but it's just that the number is still, the value for x is going to be is the same. So that's why I'm only write once. But we call that double solution. You can call it double solutions, okay, or double roots. Okay, and to the decimal of 5 over 2 is 2.5. Okay, half of 5 is 2.5. So I was able to graph. Okay, so I just wanted to show you what it look like to have a double root. Okay, so when x equal 2.5, which is 5 over 2, half of 5 right here, you see that at that x value, how the parabola is bouncing back up. Okay, the parabola is bouncing back up at that x value. Okay, so when you have double roots or double solutions, okay, the parabola is not crossing over. The parabola is not crossing over, like showing you my previous example. The parabola is not crossing over the x-axis, but at the double root means the parabola is actually uh, bouncing back up at the x value of 5 over 2. Okay, the parabola is bouncing back up. The parabola is not actually crossing over. Okay, so when you have double roots, it means that at the x value, the parabola is bouncing back up. Okay, or the vertex, or another way you can see here is the vertex is located on the x, um, on the x-intercept, on the x values. Okay, so thank you for watching my video. Okay, I just wanted to show you another example of completing the square when you have double roots. Okay, so some case you will not end up with um, two rational solution, because before I show you with a quadratic equation with two rational solution or two irrational or two complex conjugate, and I wanted to show you one with a double solution and what it looks like. Okay, so thank you for watching my video. Have a wonderful day and see you into the next one. Bye bye.